So I left off talking about specifically this process of synthetic division, and I didn't explain totally. I said the words dividing by a linear term. I should have had you write down the terms linear expression, because we're going to be dividing by an expression. And the idea behind this is that we want to try and make this straightforward in how you simplify something when you divide by a linear expression. So what I'm going to do is I'm going to line up the coefficients and make sure that everyone is accounted for, and just make sure they're in the right order. So you can see here that we have an x to the fourth, but no x cubed. So I'm going to make a note of that. So I have 1x to the fourth. I have no x cubed. I have a negative 10 x squared. I have a negative 2x, and then I have a constant term of 4. Now what I'm going to do, since we're actually in the process of multiplying, when we do long division, we subtract. I'm going to use a negative 3 up here. So you always use the opposite of the number that you see there. The first thing you're going to do is you're going to carry down the first term. Then everything else is going to be based off this number. So I'm going to times by a negative 3 to get a negative 3. Then I'm going to add this column together to get negative 3. I'm going to times again by this number up here in this corner to get a positive 9, then add the column again to get a negative 1, times by a negative 3 again to get a positive 3, and then my final thing I'm going to times again by a negative 3 to get a negative 3 and 1. So now I just have this long list of numbers, and it's important to understand what this list of numbers means. This was x to the fourth, and this was x cubed, and we would go all the way down to the constant term. So when you divide by a linear term or a linear expression, what that does is that it drops the answer for everything by 1 degree. So this now is my coefficient to my x cubed term. This is my coefficient to my x squared term. This is my coefficient of my linear term. This is my constant term. The last one is always your remainder. And your remainder is always expressed over what your divisor is. And this is a much quicker way, when you have a linear expression as your divisor, to write a quotient. So I'm going to show you this one very quickly. Notice it's all written in the right order. So I don't even need to actually write this down. All I'm going to do is write down the coefficients. So I'm going to put a positive 5 up here in this corner. So I'm going to drop down the 3, times by 5 to get 15, to get a negative 2, times by a 5 again to get negative 10, and then times by 5 one last time, and get a remainder of 0. So this was the coefficient for the x cubed. Our answer now, the one below it, will be 3x squared minus 2x plus 5. So this is always your remainder. And you can tell now, since there's no remainder, that it divides evenly into this. So because it divides evenly, this means that this is a factor. Because it divides evenly, it's called a factor. And there's a couple of things that you need to know about synthetic division. The first one is that if you divide by some value and you get a remainder of 0, then this is a factor. There's a second note that I'm going to talk about in just a minute, but what I'm going to talk about now is another thing that synthetic division is good for. It's not necessarily just for division. What I'm going to do is I'm going to show you something very clever about how you can use this. If you're evaluating a function from this book, what we've talked about is how you plug it in. And you can see that if I start to plug in numbers for x, this is a very long list of operations that you maybe don't want to do all at once to try and figure out what your answer is. So synthetic division has a specific property. When you divide by anything, it doesn't have to have a remainder. Your function value is equivalent to whatever your remainder is. So that's your second note. Okay? The second note is that your function value at that point, whatever you're dividing by, is equal to whatever your remainder is. So how does this work? Well, if this is what I'm plugging in, I'm going to put this in that upper corner, and this would be the equivalent of dividing by x minus or plus 2. But we're not dividing, so I'm just going to write down 3, 8, 5, negative 7 and see what happens. So this will be 3. This will become a negative 6. This will become a negative 4. This will become a negative 2. So this was my remainder. So if I do my algebra right and my arithmetic right here, I should get an answer of negative 9. So let's see what happens. 3 times, this will be a negative 8, so that's negative 24. 8 times 4 will be 32, minus 10, minus 7. This is going to be 8 minus 2, or excuse me, minus 8 is a negative 2, minus 7 is negative 9. So this is another way to talk about how you can use synthetic division to evaluate functions. The last thing that it's good for, and I'm going to write this down, is first of all, if you're dividing by something, if you get a remainder, then whatever you're dividing by is a factor. You can also use this to discuss what this is as a function value. The last thing is that if you get 0 for a remainder, then the point k comma 0 is an intercept of the graph. Because if it's a remainder, then your y value or your function value has to be 0. That means that it's a 0 of the function. That means it's going to be a intercept on your graph. So what we're going to do is we're going to show that these two things are factors, which means we have to get a remainder of 0. That means that they divide evenly. The word factor means divide, it's evenly into something. So I'm going to write these down. It doesn't matter which factor I pick first. I'm going to pick this one. So I'm going to put 2 in the upper corner. And let's see if it works. Yep, this happens to be a factor because we got a remainder of 0. So if this divides evenly into this expression, then the new factor has to divide evenly into the next expression. So I'm going to go even one step further with this and divide it into this expression and see if I get another remainder of 0. Let's see what happens. I get another remainder of 0. So here's my factor x minus 2. Here's my next factor of x plus 3. And here is the remaining factor of 2x squared plus 5x plus 3. I didn't write these down, but this would have been 2x cubed plus 11x squared plus 18x plus 9. So what we have right now is this factored expression that's not completely factored yet, but looks like this. So what it's asking now is to find the remaining factors. So that is asking us to factor this. And we know how to factor this. So I'm looking for numbers that add to 5 and multiply to 6. So those would be 2 and 3. This becomes a 3, this becomes a 2x, this becomes a 1, this is an x. So my final factored answer is this. And that's the final factored answer. So I'm going to look at exercise 67 right now with you. And in 67, it tells us what the polynomial is. It says the polynomial is, and I'll see if I can get this done before my time is up. 2x squared or cubed plus x squared minus 5x plus 2. And my two factors are x plus 2 and x minus 1. So I'm going to divide those into this expression. So I'm going to write all the coefficients down. And then I'm going to pick one of them. I'm going to pick 1 first because that's the opposite of this number, and see what happens. So here's my first factored expression after dividing it by x minus 1. It's 2x squared plus 3x minus 2. So now I'm going to take that and I'm going to go one step further. I'm going to divide that by x plus 2. So I don't need this remainder anymore, and I have the coefficients lined up. So I'm just going to put a negative 2 here. And I'm left with 2x minus 1. So my first factor is x plus 2. My second factor is x minus 1. The remaining thing is 2x minus 1. I can't factor that anymore because that's a linear term. Here is my simplified factored answer. So these are my factors here.